criteria. Our second criteria is that if you have all of your outcomes or all of your simple events and you add up their probabilities, it has to equal 1. So the probability of each of your events, when you sum it all up, it has to equal 1. Just like we saw with relative frequency, if you look at the probability of each of these individually, it should add up to 100%. And this is a little bit of notation that I failed to mention. When you've got a P, like a capital P, and then in parentheses something after it, it's going to be the probability of, and then whatever's in parentheses is going to be your event. So this is the probability of your simple event N. This is the probability of your first simple event. This is the probability of your event E. And so usually they'll put in parentheses, what they're looking at. So they might look at something like probability of having one boy in parentheses, and then they would write out the probability. Okay, and then we've got a probability model, right? And that's going to have all of the different possible outcomes you can have for a probability experiment, and then you're going to have each outcome's probability, so it's going to look a lot like a relative frequency distribution. You've got your different outcomes, you've got all of their probabilities, which is going to be similar to relative frequency, but I'm kind of getting ahead of myself, sorry. But when you list out this probability model, it has to meet rules 1 and 2. So you will have some questions. Do we have them listed? Nope, we don't. Okay, never mind. We'll do those from the homework next time. Where we have some that aren't, we'll talk about why they aren't. Probability models. Okay. So for this one, they want us to verify that it's a probability model. They look at a large bag of M&Ms, and they've got all the different possible colors, and then their associated probabilities. And then they want us to make sure that this is a probability model. So the first thing we need to check is that all of our probabilities are between 0 and 1. So 1, we need to check all probabilities. 1, is that true? Yeah. So we don't have anything negative, we don't have anything that's greater than 1, so that one's going to be met. And the second thing we need to check is that the sum of all probabilities is 1. And that one we need to add them up to see. And these are all simple events, so we can go ahead and just add them together. So in our calculator, we'll just do 0.12, 0.15, oops, 0.12, 3, 5. When we add them all up, we get 1, which is great. That's what we want. These are met. So it is a probability model. And then I said, technically with probabilities, you can include 0 and 1. So if probability is 0, that means it can't happen. So if an event is impossible, the probability of that event is just going to be a 0. So if you're looking at rolling a die, what's the probability that you get a 7? That's just going to be 0 because you can't roll a 7 unless your die is not standard 6-sided die. And then the other one is if it's a certainty, the probability is going to be 1, so that's 100% definitely guaranteed to happen. So if you roll a die, what's the probability that you get a number that's less than 10? Well, that's guaranteed to happen because all the numbers 1, 2, 3, 4, 5, 6 are all less than 10. So that probability is just going to be 1 because it's guaranteed, it's a certainty. All right, and then the last one right here is an unusual event. And that's going to be a technical term that we're going to use throughout this, the rest of this book. they'll ask you, after they ask you to find probabilities, they'll say, is this unusual? It's not gonna be an opinion question. You're looking to see if it's less than 5% or not, okay? So, when you go through and calculate these things, if you get a probability that's like 5.5%, we're not gonna say that's unusual. It's not very likely, but that term unusual is reserved only if the probability is less than 5%. So if it's 4.9%, that one will say it's unusual. Okay, so that's not an opinion on whether you think it's unusual. It's, does it clear this 5% cutoff point or not? Okay, so less than 5% is unusual, more than 5%, it could be not very likely, but that term unusual, we're not gonna use if it's greater than 5%. Okay, I'm actually gonna do these in a different order, so bear with me. I'm gonna come down and do the classical approach first. So I'm skipping the empirical and I'm gonna come down here